you seeing a pattern, right? What to look out for, trying to avoid making those small mistakes that throw you off, right? Just getting better at it. Finding a balance between taking your time, making sure you're doing it right, and also getting it done in time so that you're not running out of time with other questions, right? So a word problem which involves 2 to 3 inequalities, can take you 10 to 12 minutes if you're fairly good at it. That would ensure that you have a proper scale and all of that when graphing it and labeling and all of those things, right? Like, so 10 to 12 minutes for a bigger word problem is quite normal. Okay. All right. So we have this first example here. And maybe actually for time's sake, I'm just gonna fast forward. I will do the word problem with you though. Okay. So, and I will post this answer key so you don't have to frantically write everything down. I think I'd rather you pay a bit more attention. Okay. Pay attention to what's happening here. So again, we find the intercepts for all of them. I have a special case, a horizontal line. That should be fairly normal. You should have noticed that you had a -14 y-intercept. I rewrote everything. I had to pay close attention to, this second inequality where the y, right, has a negative coefficient, and you're going to have to divide it, right, by negative. And that flips the sign. That's probably one of the most important things in this example, or else the shading is in a completely different pane. Okay. So when you flip the sign, you end up with this. I make a note for every single one that you have a solid line here. True is below the line, so I'm going to shade above. Over here, it's solid because of the equal, right? The line is part of the solution. Above is true, so I'm going to shade below. Then over here, the third one, it's the same as, it's pointing the same way as the one before. So it's a dashed line because it's only greater than. Line would not be part of the solution, and you shade below as well. You label your x and your y axis. You account for appropriate scale. Notice that I extend my lines way past so that in the event that the corner point, for whatever reason, is far out there, you can tell that they're going to meet. And therefore, you might have to increase your scale, right? You might have to say, oh, wait a minute, that doesn't work. This is my strategy for you, okay? Let's say it doesn't work. It's way far out there. Instead of erasing the whole thing, maybe it would be better to just increase your scale, like go up by 5s instead of 2s or something, right? So that you can fit it on your grid. Obviously, the lines you will have to re-graph because your intercepts will change, right? Like, I mean, they stay the same, but because of the scale, you'll have to move it. But instead of you completely erasing or having to extend it because you're out of room, just increase your scale, go up by 5s, go up by 10s, whatever the case may be. Anyways, you end up with this. So your corner points are where the different lines meet. So you have 3 corner points, and they're somewhat tricky to get with your calculator. And just remember, you just jump, go up and down with your arrows to, like, right, if you're, let's say this is the first line you've entered. So let's say you want to find the intersection between these 2 lines here. You scroll closer to this, hit enter, then it might jump to your second line, but you don't want that. Just go arrow up or down, cycle through your lines until you're landing on the horizontal, and then move closer to the corner point you're interested in, and then you find this one. And another nice thing about your calculators is that the color of the line matches the coordinates as you're tracing through that line. I don't know if you've noticed that, right? So it will go from red to blue to black or whatever your colors are, and there it is. So there were 3 corner points that you had to find in this. Sometimes, just so you know, this is also called the solution polygon, right? Many sides. Polygon stands for many sides, so it could have more than just 3 corner points. It depends on the situation. So don't let that throw you off if you ever. I think there's going to be a worksheet that asks you for, you know, label your solution polygon. It's just label the solution region, right? And so forth. So this would be the first one. I was able to fit it on here. If you had to do it on loose leaf, then so be it, okay? So that's something that I expect you to do. However, don't think it's always going to be a triangle, right? Don't think it's always going to be. Let's say, for example, this would have been, right, this line would have been have to have shaded below the line, right? Then your solution region would have been this section right here, right? The dashed line where it meets here, all of that would have been gone, right? So, or that would have been your solution region, I mean, to say that. And so be careful with not always assuming that, okay? But for the most part, it has been a triangular. It just makes more sense to find the corner points, and it gets you to practice. And this one I'm going to do together with you. Sorry, I didn't want to give it away just yet. And if you were here, my sub, he was actually a former math teacher here at Sisler, so I think he wrote down in his notes that he worked through those first 2 with you. Anyways, here it is. Mind you, these steps right here that I'm asking you to go through may or may not be there. It might just tell you, to graph the system and come up with all possible solutions, right? But this one kind of walks you through it, okay? So, A, define variables and state the implicit constraint. We're going to do that, but first let's read through it. Biff and Chip are moving. They're packing their items into 2 boxes, small and large. So hint, hint, right? What are our variables going to be? Small boxes and large boxes, right? The small boxes can hold 3 cubic feet and cost $1.85 each, while the large can hold 8 cubic feet and they cost $3. Mind you, so far there are no restrictions placed at all. They're just giving you information. The truck they rented can hold up to 180 cubic feet. That's right there, can hold up to, oh, it's smudging there. Up to, that's a restriction right there. Okay, can hold up to, so that's saying you cannot fit more than that into the truck. So sometimes it says they have 180 cubic feet available to them. That is also a way of saying that's the maximum they can hold. Okay, so that's restriction number 1. So we know we're going to have one inequality for sure. Biff and Chip would like to spend no more than $85 on boxes. There's another restriction. No more than $85 to be spent. Okay, that's my second inequality that I'm expecting to appear. Let's continue reading. Given the large items they own, they will need, so they figure they will need at least 10 large boxes. Okay, so in this case, folks, you have 3 inequalities. And we'll talk about that as we get there. Let's just focus on A, define variables, state implicit constraint. So we will let X be number of small boxes. Y will be the number of large boxes. Good. Implicit constraint, X and Y have to both be greater than or equal to 0. And we're talking number of boxes. So we know that this is discrete data, okay? Just making a note of that. I'm telling you to put that down to remember if you find the corner points. In this case, you'll have to round them to whole numbers, okay? B, write the linear inequalities. So let's come up with those, okay? Let's deal with the first one. You can hold up to 180 cubic feet. Obviously, they mention how much cubic feet each box can hold. So in this case, you'll have to just say, well, if there are 3 cubic feet per small box and 8 cubic feet for every large box you get, that combination of boxes, right, has to result in less than 180 cubic feet. So there's a restriction, right? There's a max of 180 cubic feet allowed. Okay? So that takes care of the first inequality right there. And then it says Biff and Chip would like to spend no more than $85 on boxes. So then you kind of want to look for, is there an indication, is there a coefficient that will accompany each box? And yes, there's a $1.85 here and $3 for a large box. So it's $1.85 for a small box and $3 for a large box. And that combination, right, the amount of boxes you get, you plug that in, the cost would have to be less than $85, right? This is your cost is maximum 85 bucks, right? So because this talked about a dollar amount, we went and got the dollar amounts associated with each variable. This one had cubic feet, right? I don't know why I put that down. I shouldn't have. It doesn't really matter. Not a big deal. We'll just leave it there. But then I'm like, okay, the cubic feet is going to go there. Okay. So one inequality done, right? We took care of this one. And then there was the other one which mentioned that they need at least 10 large boxes. This is an interesting one. This restriction is exclusively towards the large boxes, right? So this is a special case where y, the number of large boxes, has to be greater than or equal to, right? At least 10, right? At least 10 large boxes. So I kind of make a note, like, right? I'm checking off my inequalities as I go. Okay? And there you have it. Now, got to be careful that you don't read in an inequality that actually does not exist. For example, a lot of you have had, and I'm going to use scrap here, right? A lot of our examples had something like this: x and y is less than or equal to 20, right? Like, where it's just x and y. I will translate this to you. If the question had said that the combined number of boxes have to be less than 20, or they can have a maximum of 20 boxes in total. If something like that had been mentioned, then yes, something like this, because it's the number of boxes, right? Small and large combined have to be less than 20. But this question doesn't say that, okay? It doesn't mention anything like that. This is just specific to the large boxes because they have large items. Okay, so that's what you got to keep in mind. Like, what am I reading? What is the question saying? Okay, so we did that. We did A and B. Now we want to graph this. So obviously this now turns into a graphing question, which you've just done in A. Okay, so I will for C just write them out here. So you've got 3x plus 8y is less than or equal to 180. And you got to be mindful of your space, even on a test, okay? So start somewhere like right tucked up against the corner, because you kind of have to assume you're going to use up a lot of that room. Okay, so it's 3x is equal to 180. Divide both sides by 3, x is equal to 60, 60, 0. So this one I'm going to fast forward a bit. I have it worked out here. 8y is equal to 180. And some of the nuances here is that some are giving us some ugly decimals, right? It's not a finite, and so we have to be comfortable with that, okay? I'm going to rewrite it. 8y is negative 3x plus 180. Divide everything by 8. Oops. Y is less than negative 3 over 8. X plus, this one is finite, so you can just write it like this. Okay, so we can box that in. And this is going to be solid. I'm going to shade. True is below the line, so we're going to shade above. But remember that the true region is below. Okay. Next, I'm going to take my second inequality. That's the one that doesn't work out nice and neat, and you have to be comfortable with that. X-intercept, y-intercept. And now you know why I'm making you putting it in a chart, because if it's all organized, then it's way easier to graph later on. So 1.85x is equal to 85. I'm going to divide both by 1.85, and you get 45.95. 45.95, 0. Okay. And then the y-intercept is 3y is equal to 85. Divide both sides by 3. Y is equal to 28.33. So that's 0, 28.33. Rewriting it, we get that. And this is one where you want to leave everything as is. And we have a calculator to help us with that. So we don't need to worry about how ugly the fraction is, right? Or how complicated it looks. We just type it in, making sure we use brackets, right? So this is a solid line. Because it's less than, the true region is below. Remember that. So we will shade above. And if you need to write that still, like true is below, shade above, to remind yourself, then do it, right? And then the last one here is that y is greater than or equal to 10. It's a horizontal line, and it goes, it'll be at 0, 10. And it'll be solid. And because it's greater, true is above the line, so we will shade below. So there are my three inequalities back to back. I will graph it now. And remember, it's a word problem, so we stick to the first quadrant here. Number of small boxes, number of large boxes. And I'm going to go out to like 50, 60 in the X, and about 30 or so on my Y. But you know, if you just go up by tens going each way, you should be fine. So it would be 20, 40, 60, one more just for good measure. 1, 2, 3. Okay. 20, 40, 60, like that. So let's go with the first line. It's 60, 0. And this would be 30. This would be 25 here. So it's between 25 and 20 right here. Graph that line, solid line. Just watch the wording in case it's not always a solid line. Okay, and then we have the next one, which is 45.95. So it'd be right about here. And we've got 28 0.33, which is above that previous, so they actually intersect. Okay, so you've got your two lines there, and then we have the y equals 10 boundary line. And there you have, so this is y is greater than or equal to 10. This line here, I'm just going to go out here and say this is the 1.85x plus 3y is less than or equal to 85. It just probably looks better like that using that version. And then this line here, it's 3x plus 8y is less than or equal to 180. Okay. And now we have to shade. Okay, you have to make sure you shade in and you label your solution region. How about we start with this, the horizontal line? It says to shade below the line, so we're going to go ahead and do that. Okay, so that's all gone. Let's go with this line, which is this one here, and it says to shade above, so we're going to focus on that. Just going to follow that line. Basically everything above that line is gone. Right? I'm going to focus on the last one, which is this one, and it also says shade above. So you just got to make sure that that little sliver is also taken care of. The rest is already taken care of, right? Because it's the previous line already canceled out everything. So this little sliver here also needs to now be canceled, okay? Now, your corner points. There's one right there, one right there, one right here, and this one is harder to see, but it's right there. So this is actually a solution polygon, right? It's not a triangle, even though a triangle is a polygon, but sometimes the worksheets will refer to as the solution polygon, not a big deal. So you just label this as solution. And I will actually walk you through how to do it. Okay, so I'm going to enter that all into my calculator. (185) divided by 3x plus 85 divided by 3. And in this case, because you have no vertical line, you can actually type them all in. Okay? They're all like this. You can graph all three. And let's see what happens. I guess I have to do my zoom. I was doing something else earlier with it. So we're gonna go zoom or window, sorry, window. And yes, I want to be just below, and my X max, if I just go up to 70, I'm fine. Sorry, this should be -5, but this will be 70 there. My Y min just below the X axis, and the maximum should be, like, if you're in the 50s, you're fine there for your Y max, right? So you just go by, right? That's why finding the X and the Y intercepts help you there as well. Hit graph, and you see them there. There they are. And notice that we're only interested in, right, the corner points here. So the blue line. This one we already know. This one we know, so we're just going to read that. How about we write them down already? Because we've calculated that. So corner points down here. This is 0, 10. This one right here, I already calculated is 28.0, and then it's 28.33. This is just, I read it off. I read this one off. And now I'm going to find these two here yet. So it kind of saves you a little bit of time there. So we're going to go second trace 5. And I'm interested where the blue meets the red there. So I'm going to go enter, and it just happens to jump right onto the red. See how everything turns red? That means that you're now on the red line. And guess, and yes, it's 24.14. This is going to be a little complicated for what I want to do here. How about I just leave some space here? It's 24.14, and it's 13.45. That's that one right there. And then second trace 5 again. Now I'm interested in where the black meets the red. So I'm going to go see, I went arrow up. Let's jump to this one. Why not? I'm going to jump here, hit enter. And now it's on the blue line. Watch, like you're on the blue line, but that's not the one you want. You want to get to the red. So cycle through until it's red. Everything on your screen is red now. And just get as close as possible to that point, and it's 29.7310. Okay, so this one you use your calculator for. Calculator. All right, now this one is good. It's discrete data, right? This one we want to round it to 0.28. Wait a minute. Sorry. Did anybody catch that? This is not the 28, folks. This is the 22.5. So we gotta correct this. This is the 22.5 point here because it's the lower one of the two, right? So that rounds to 23. This one rounds to 24 and 13. This one rounds to 30, 10. Okay, so just round up or down to the nearest whole number because it's discrete, right? Make sure you take a note, make a note of that. These are the corner points that we will later on use to actually answer, right? Like what combination should they be using out of these highlighted ones? We will find out that there is the solution. Right now we give them a couple, and it's out of these corner points where you get the ultimate, the best answer down the road, okay? All right, so I will